So hello and welcome to this new video in which we'll be exploring different advanced retrieval methods, and then we will compare each method against each other on a synthetic generated dataset using Ragas, and we will be evaluating in LangSmith. So as always, first things first, we instantiate our OpenAI API key, our Cohere API key. We load the data here, which is important is that we need these columns for metadata, and what the retriever will be actually retrieving is the page content. So next, we instantiate our embeddings, and we are ready to set up our quadrant vector store. Next, we do the first retriever, we instantiate the first retriever, which is the naive retriever with k equal 10. We instantiate our RAG template, the augmented part, and our RAG prompt. For the generation, we are using GPT 4.1 Nano. And next, we instantiate the LangChain expression language RAG chain. So here in this chain, what we have to pay attention to is this runnable pass-through, as we need to maintain the context, because in this case, we are returning not just the model response, but the context. So we here test the naive retrieval chain, and next we do the same with the best matching 25. We instantiate the retriever, instantiate the chain, and we test it. Next, we go with the contextual compression using re-ranker. So for the re-ranker, we are using Cohere with the re-rank B3.5, and we create the chain, and we test the chain. Next, we go with a multi-query retriever, and this retriever takes the naive retriever and creates different variations of the query. We instantiate the chain, we test it, and we must explain how generated multiple reformulations of a user query can improve recall. And this is because by having slightly different ways of expressing the same intent, we allow the system to retrieve more relevant documents that a single embedding might overlook. Next, we go with the parent document retriever, which explains in simple terms what it does is search for small documents and return big documents. We will be using for the child splitter the recursive character text splitter. And as we need to someplace to store the parent documents, we need to instantiate a parent document retriever in memory. So we do that, we add the documents to the vector store, we instantiate the chain for this parent document retrieval, we test it, and next we go with the ensemble retriever, which in this case, what it does is combine various retrievers. It's an ensemble of retrievers, and we retrieve every document and weight the responses using reciprocal RAG fusion algorithm. In this case, we will be weighting the responses with equal weight. Next, we instantiate the chain, as always, we test it, and now we go with the semantic chunking, that, as we know, semantic chunking is not a retrieval method, but we can leverage it to assemble our retriever. So we instantiate the semantic chunker, we split the documents with the semantic chunker, we instantiate a quadrant vector store for these semantically splitted documents, instantiate our retriever, create the chain, and then test it. So if sentences are short, something that we must mention is that the semantic chunking tends to overmerge because everything looks similar. So to fix it, what we can do is to tighten the similarity threshold or set fixed size rules. That is what we are doing here with the breakpoint threshold amount, for example. Next, we go with the activity 1, which is creating a golden dataset, then a generate synthetic data from this dataset, and next we are going to evaluate. So we instantiate LangChain API key with the tracing true, the name of the project, we load the data, and here what I have done is to expand the content that page content is going to have, that, as we know, the retriever is gonna look in this page content for the responses. So as we have artificially expanded this dataset, we need to create new vector stores using the expanded dataset and then recreate all the retrievers. So here is what I have done. Next, we can continue with our synthetic data generation. We instantiate the generator LLM, the embedding LLM, the knowledge graph. We append the documents to the knowledge graph. We use the default transformations to create the relationships. We have here these many relationships. And next, what I wanted to do is to create some personas, that this is how I imagine that my users will query or question my system. Next, I must say that I have chosen only to do single hop specific queries, because I find that multi-hop specific queries are best suited to larger knowledge bases and in cases that you need complex reasoning. Here we have the dataset. And next we can go with the evaluation. For the evaluation, I have used the RAGAS metrics, and to be able to evaluate within LangSmith, I have used the evaluator chain, which are just wrappers. So here, the only thing to mention is that I have created a factory function that receives each retriever and returns a chain. We run the chain through each chain through the test set to append the context and responses, the responses each chain has generated and the context that has used. Then we create the client. We create the test set in the format that LangSmith needs, and then we are ready to evaluate. And now let's go to the analysis. So here we have the results of comparing each of the models, of evaluating each of the models. And what the most important thing I must say, or the best model, has been the contextual compression or the re-rank. Why? Simply because it has achieved better metrics than the other ones, and it has with a moderate latency. So that's all for this video, and thank you so much for having been here with me, and bye-bye.